Hey guys, we're going to go through problem set 3, and problem set 3 was for the end of chapter 5. And what problem set 3 started out with was having us consider these functions. There's 5 of them here. I'm going to refer to them as f, g, h, p, and q. And it wants us to determine some characteristics about these. So first things first, we can factor this top one. It's the only one that can be factored. The top can be factored into x minus 3 and x plus 7. So let's go through some characteristics here. State the function, if any, that do not have a vertical asymptote. So vertical asymptotes happen when the denominator is equal to 0. So for the first one, I know that the x minus 3's can cancel out, which would mean I still have x minus 4 on the bottom, so vertical asymptote would be at 4. For the second one, although these x minus 4's cancel out, we still have x minus 3 on the bottom, so there would be a vertical asymptote at x is equal to 3. For the third one, I cannot get 0 on the bottom here. No matter what, x squared will be at the very least 0. I can't get negative numbers. Multiplied by 3 and add 1, I can't get a 0 there. So h cannot have a vertical asymptote. For p, I'm going to have a vertical asymptote at 3 and 4. For q, I'm also going to have a vertical asymptote at 3 and 4. So h is the only one that would not have a vertical asymptote in this case. So I'll put that back in there. Next one, state the function if any ones that have a horizontal asymptote. So remember, a horizontal asymptote happens when the degree as a numerator and denominator are the same, or if the denominator's degree is higher. So I'm just going to write out the degrees. Degree of the first one is 2 over 2. So that's the same, so that would have a vertical asymptote. So f would be part of that group. For g, degree on top is 1, degree on the bottom is 2. So that would also have a vertical asymptote. In that case, it would be at 0. H, degree on top is 4, degree on the bottom is 2, so it would not have vertical asymptote. For P, degree on top is 3, degree on the bottom is 2, would not have a horizontal asymptote. I might have called it vertical earlier, but horizontal is what we're looking at. And the last one has a degree of 1 as the numerator and 2 as the denominator, so that would have a horizontal asymptote at 0 in that case, Q. Question C says, state which functions have an oblique asymptote. And that happens when the numerator's degree is 1 more than the denominator. And the only one that has that is P. Numerator is 3, denominator is 2. So P is the one for that. Change the color as we move on. Next one talks about x-intercepts. Whoops. Which of the graphs do not have an x-intercept? So an x-intercept happens when the numerator is equal to 0. So for the first one, if I simplified it, I know that the numerator will be equal to 0 if x is equal to negative 7. So it has an x-intercept. For the second one, if I cancel out x minus 4, that leaves us with 1 over x minus 3. I can't get a 0 on top because it's just a 1 on top. So g would be part of that group that does not have an x-intercept. H, I cannot get 0 up top here because I'll have 7x to the power of 4 plus 1. X to the power of 4 at the very least can be 0. Can't be any negative numbers because it's an even exponent. So I'm not going to be able to multiply the 0 by 7 and then add 1 and get 0. That plus 1 tells me it's 1 above. So I know H is going to be part of that group that does not have any x-intercepts. P, can I get an x-intercept of 0 here? Sure. We could have 9x3 plus 8 equal to 0. I can take 8 to the other side. It becomes negative 8. I can divide by 9 and then take the cube root. And we can take a cube root of a negative number. So yes, we could take a cube root of that. So that one would have an x-intercept in that case. So there is a possible answer. And for the last one, we would have an x-intercept here at negative 1, because negative 1 would make that numerator 0. So the only ones are g and h in that case. Next one, state the function if any that have a hole at 3. So the first one, f, would have a hole at 3 because I would cancel out that x minus 3. When we cancel out, that tells us that there's going to be a hole. So f, that's the only one that we would cancel out. As we continue, state the function if any that have a vertical asymptote at 4. So let's go through these ones. First one, if I cancel out, has a vertical asymptote at 4, so f. Next one, I would cancel out x minus 4, does not have vertical asymptote at 4. Next one, if I substitute in 4, I would not get 0 as my denominator. This one here, if I substitute in 4, I would get 0 as the denominator, so P would be part of that. And this one here, if I substitute in 4, I would get 0 as my denominator, so Q. All right, so we'll keep rolling along here. Next one says solve the following equation. So since it's an equality, we can multiply both sides by values, no problem. Remember, inequalities we can't if the denominator, if what we're multiplying by is a negative. So in this case, I'm going to multiply both sides by x minus 1. So I'm going to write that out here. We're going to have x plus 3 is equal to 2x plus 1 multiplied by x minus 1. So when I expand that right side, we'll end up with 2x squared minus 2x plus x minus 1. Add together any like terms that we have, so 2x squared minus x minus 1. Then I'm going to bring x over to the right side. So what that's going to do is it's going to make this negative 2x. Right, so we're subtracting an x. I'm going to bring 3 over to the right side. It's going to make this negative 4. So I'll end up with something that looks like this. And we're trying to solve that. It's a quadratic. I can either factor to use quadratic formula. I'm going to try to factor it first. I see they have a common factor of 2. And then I try to factor what we have in that bracket. Two numbers that multiply for negative 2 and add for negative 1 are negative 2 and positive 1. And we solve this. X is equal to 2 and x is equal to 1. Keep rolling along. Question 3, we want to graph the reciprocal. So remember, one of the rules was with the reciprocal, anywhere there's an x-intercept is a vertical asymptote for the reciprocal. So I put 2 lines at those. Next, I know that when we're dealing with the reciprocal, we have a horizontal asymptote at 0. And we know the graphs need to be in the same sections of the graph. So I know it's going to be up here, I know it's going to be down here, I know it's going to be up here. So if it's up in the top left-hand corner, the only option is something that looks like this. In the middle, I know it comes from the bottom. Since this is at negative 1, its reciprocal is also negative 1. So I know that my graph is going to touch at negative 1. And it must come back down. Right, that minimum was at negative 1, so the reciprocal of negative 1 is also negative 1. So that's why our reciprocal touches negative 1. And it has to be up in the top right-hand corner, so I know it's going to look something like this. So that's our reciprocal graph, the green one. Next, we'll keep going. Determine the domain and range of this function. So domain means that we want to find out the values that x can be. So we see a quadratic on the bottom here. I know that x can be all values except values that make the bottom 0. So domain, x is an element of real numbers such that we want to see, are there any values that make this 0? So what I can do is try the quadratic formula, see if any values will make it 0. Remember, negative b plus or minus the square root of b squared, so negative 6 squared is 36, minus 4 times 1 times 20. If I put this into my calculator, I'm going to get a negative number. So there is no solutions to that. So that means there is no way I can get an x that will make the bottom 0. So this is just x is an element of the real numbers. Our range is a little more difficult. So in a case like this, I got to see what my function's vertex is. So if I was to complete the square with the bottom here, I would have x minus 3 squared plus 11. So if I graph just the bottom, right, but not the reciprocal, that is the reciprocal. If I just graph that quadratic, I know that I would have some graph that would be 3 spots to the right and 11 spots up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. If I was to graph, I know this is really rough. And it would open up. So a reciprocal, I know that the graph is going to have a horizontal asymptote right along 0. I know it's going to be in the same sections of the graph, so it's got to be up top, right? Not going to be below. So I know it's got to approach along here. It's going to come up, but then how high is it going to get? Well, if this number's at 11, its reciprocal will be at 1 over 11. So that must be the maximum that this graph gets. So it's going to be all the values between 0 and 1 over 11. That'd be the range. So I'd say y is an element of the real numbers. but y is between 0. I'm not going to put 0 is equal to, less than, y, and y is less than or equal to 1 over 11, because it would touch that. Right? It's the reciprocal of the original function. So I had to take that original one, which is the bottom, and figure out what its vertex is, because that's the minimum of this one, so it'll be the maximum of the other, but the reciprocal of that. So I would just basically take 11 over 1 and flip it to 1 over 11. So that's kind of a funny question, but that's that one. You could use Desmos and graph that if you wanted to see what it looks like, but that's what that graph would look like. So we have our domain range. Keep rolling along. Next one, determine any points, if any, at which the function f of x is equal to x squared minus 8. So I know that a reciprocal and its original function will meet. They share y is equal to 1 and y is equal to negative 1. That's the only spots where they share. So if they share those, I want to figure out, well, what is our function if y is 1? So we're going to, oops, negative 8. So I'm going to solve this, bring 8 over to the other side. We get 9 is equal to x squared. We're going to get x is equal to positive or negative 3. So points that they share are 3 and 1, negative 3 and 1. Then I would do the same thing for when x is equal to, or sorry, when y is equal to negative 1. So do the same thing, maybe a different color for this one. So when it's equal to negative 1, x squared minus 8. So when I bring 8 over to the other side, I'm going to get 7 is equal to x squared. Right, we're adding 8 to both sides. And when I square root, I get positive or negative root 7. Right, or 2.2 something. So what does that mean? Well, that means that we have points at positive root 7 and negative 1 and negative root 7 and negative 1 is where those points would share. So they only meet where y is equal to 1 or negative 1. Why? Because the reciprocal of 1 is 1 and the reciprocal of negative 1 is negative 1. Those are the only two numbers where the reciprocal is the same value. So those are where those ones would meet. Keep going along here. So for question 6, if I wanted to sketch that one, I'm going to have to factor the top. So I'm going to get f of x is equal to x minus 5, x plus 2, all over x minus 1. So we go through the characteristics that we know. There's 4 main ones that we talk about. We say, where is the vertical asymptote? Well, it's going to be at 1, because that's where the denominator is equal to 0. In this case, the horizontal asymptote, well, degree on top is 2, degree, so there's none. Next one, we're going to have oblique asymptote. So for oblique asymptote, what we're going to have to do is divide these. So I'm going to have to take our equation and divide it. I'm going to use the original equation up at the top, the x squared. Coefficient was 1, negative 3, negative 10. And when I factor this, we're going to get 1, add those together for negative 2. But what we're interested in is not the remainder, but the equation. So the equation of our oblique asymptote is y is equal to x minus 2, based on our divisions. Then I need to know my x-intercepts. That's where the top of the graph is equal to 0, and I know that's going to be at x is equal to 5, and x is equal to negative 2. And the y-intercept, that happens when I input 0 for x. So if I input 0 for x, I'm going to have negative 10 on top and negative 1 on the bottom, which is equal to 10. So these are all the characteristics that we have. If I want to graph this, I know I'm going to have a vertical asymptote at 1, so I'm going to put on 4, 5, 6, 7. Put our graph on here, vertical asymptote at 1. Horizontal asymptote, we don't have any. Oblique asymptote at x is equal to negative 2. Right, that line is y is equal to x minus 2, so x slope of 1, y-intercept of negative 2, so it starts 2 below. My x-intercepts are at 5, right here, and at -2 right here. So I can kind of tell what sections of the graph it's going to be in. It's going to have to be in this area and this area based on those x-intercepts. I have a y-intercept of 10, so way up here. So I can imagine that this graph's got to look something like this. Maybe use different. Continue up along that horizontal asymptote here. And since it's in this section, it's got to come along here, like so. So that's question 6. And we'll keep going to question 7. Question 7 says Pedro bought a box of rare Math Wars comic books over the internet. He paid a total of $750. Pedro kept 10 for himself and sold the rest for $900, making $20 profit on each book. How many books did he buy initially? So very similar to that one that we saw before with the hats. So same idea, I want to come up with that. I want to know what was his revenue minus his cost equal to profit. And these ones are giving me information per book. Revenue per book and cost per book. So let's see, revenue, how much did he get? We know that the value of X will represent how many books he bought. So he kept 10 books for himself. So he sold 10 less than he bought. And we know that he earned $900 for that one. I want to subtract my cost. Well, he paid a total of $750 for the books. Per book, he bought X of them. So when I divide that, it would be cost per book. In total, it told us that he made $20 per book, so that's equal to 20. So this is the equation that we're going to try to solve. We want to figure out what X is. That's the amount of books that he bought. So what I'm going to do is get common denominators. So I'm going to have to include X on the top here and X on the bottom. I'm going to have to include an X minus 10 here and an X minus 10 here to get common denominators over here on the left side. So I'm going to have 900X minus 750 X minus 10 all over X minus 10. That's still equal to 20. So when I distribute inside, I'm going to get negative 750X. And I'm going to get positive 7,500 when I distribute here. So I'm going to have 900X minus 750X plus 7,500. All over X minus 10 is equal to 20. I can add the two like terms that I see together on the top, 900 and 750. That's just 150. So I'm going to take that out. Add them together, 150. And now I need to solve for X. What I can do is cross multiply. So I'm going to multiply both sides by X minus 10, for example. Something like that. Distribute the 20 inside, get all my like terms together. So I'm going to have 20x squared minus 200x. Sorry, it's 150 had x on it. Bring it over to the left side. It's going to be negative 150x. And negative 7,500 is equal to 0. Add my like terms together. From there, I can common factor it if we want to. I can use quadratic formula. In this case, let's just use quadratic formula, make our life a little bit easier. So negative b, so 350 plus or minus the square root of b squared, so negative 350 squared minus 4 times 20 times negative 7,500 all over 2 times a, which is 2 times 20. We get 40. 350 plus or minus, we put all of that into our calculator. 350 squared minus 4 times 20 times negative 7,500, and then we have to square root that number. And we'll get 850. And we have two possible answers for this. I know that the negative one's not going to apply because when I subtract across the top, I'm going to get a negative number. Then a negative number divided by 40 is going to be a negative. Just to show you, 350 take away 850 is negative 500 divided by 40. We get negative 12.5. He couldn't have bought negative 12.5 books. So I'm going to have to try the other one. That's the addition one, 350 plus 850. That gives us 1,200 divided by 40 tells me he bought 30 books. So that's our answer to this one. Pedro bought 30 books. You could have factored and solved it other ways, maybe use quadratic formula. Regardless how you look at it, it's going to be 30 books that he bought in this case for all that to work out. That's 7. Keep going. 8. This one was like the mowing the lawn in this case was like lining the field, one of those examples that I used in our notes. So this one, together Joe and Jim can mow the lawn and a golf course in 6 hours. When working alone, Joe can mow the same lawn in 10 hours. How long did it take Jim to mow the lawn alone? So let's go through this. So we're going to say Joe, Jim, and together. So Joe can mow the same lawn in 10 hours. So he's 1 over 10. One lawn in 10 hours. Add that to Jim. Jim, we don't know how long it takes him. 1 over x. That's how long it takes Jim. X hours to do it by himself. That'll be equal to, together, we know it takes them 6 hours. And that's the expression that we're trying to solve. Joe does 1 lawn in 10 hours. Jim does 1 lawn in x hours. Together, so when I add them, they do 1 lawn in 6 hours. So in this case, I'm going to have to get common denominators. So the common denominator here is going to be 10x. So how do we get that? Well, I'm going to have to add an x to this side. And I'm going to have to multiply that by a factor of 10. So essentially what we're going to get is x plus 10 on top. Over here, we're going to have 1 over 6. From there, I can cross multiply. 10x times 1 is 10x. 6 times x plus 10 is 6 times x plus 10. Distribute inside. 6 comes over to the left side, 6x comes over to the left side, so we're subtracting it. We're going to have 4x is equal to 60, and I can divide both sides by 4. X is equal to 60 divided by 4 is 15 hours. So Jim can mow the lawn in 15 hours alone. That is one heck of a lawn. But that's how those ones are done. So individuals and together. It's one in your book about 2 machines working together with chocolates or something like that. So have a look at that one as well. But that's that one. Keep rolling along. Pause it at any time that you need to look at any work. All right, for question 9, it says, as we graph the reciprocal of some function f of x and obtain this graph here. So that's what the reciprocal of f of x is. It says, determine what f of x is. So in order to do that, well, I need to find the equation of this over on the right and then flip it so I can get the reciprocal of it. So there's 2 pieces of information that I need to get from this. First one is vertical asymptotes, because that's going to tell me what the denominator is of this function right now. I see it's at 2. So that means the denominator is x minus 2. There is a horizontal asymptote at -3. So that's going to give me some information about the top. I know that because the horizontal asymptote is not 0, I know that the top numerator and the bottom denominator have the same degree. So the degree right now is linear, so I know it's going to be some like mx plus b thing, right? Linear. Now, how do I find this information? Well, because the horizontal asymptote is at -3, I know that the division of the leading coefficients will be -3. So m divided by 1 has to be -3. Well, that means that m must be -3 then. So that leaves us with only one other piece, that b value. So how do I get that b value? Well, all of this is equal to y. So what I'm going to do is choose any point on the graph. I'm going to choose 3 and -2, and I'm going to substitute that in for x and y and try to solve for b, because I know it's a linear on top. I just don't know what that b value is on top. So let's take that equation and substitute it in. So I'm going to put in -2 is equal to -3x, which is 3, plus b, all over x, which is 3, take away 2. And it's a matter of solving this through to find out b. So if I'm solving this, I'm going to have -2 is -9. On the bottom, I'm going to have 1. So I can put over 1 if we want, but it's going to be the same. And find b, I got to bring -9 over to the other side. I'm going to get 7 is equal to b. So that's the equation of this function. So I'm going to put this up at the top here, and then we'll get the last part of it. So that equation that we have up at the top, once again, if you need any of it, you can pause it and go back. But that equation up at the top is the equation for this. Question says we want to know what the reciprocal of this is. So what I'm going to do is just flip it. So y is equal to x minus 2, -3x plus 7. That would be the reciprocal to this function. So that's that one. Keep going along here. This one says solve for x in the following inequality. So if I'm solving for x, that means we're going to need a interval chart in this case because we have an inequality. But what I'm going to do is try to factor the top and bottom first. Whoops. So when I factor the top and bottom first, we're going to get on the bottom x plus 5, x minus 4, not equal to, just less than. And on top, when I factor that, we're going to look for two numbers that multiply for -6 and add for 5. We have that. Let me just double check here. Yep. So I want to know when this is greater than 0. So I'm going to use my interval chart. So my x-intercepts in this case happen to be at -3 and half. My vertical asymptotes in this case happen to be at -5 and 4. So when I make my chart, I'm going to have all my factors here, 2x minus 1, x plus 3, x plus 5, and x minus 4. So our interval chart's going to start from -infinity and come to the first number, which is -5. Next one starts at -5, goes to the next number, which is -3. -3 to the next number that comes, which is half. Then half to 4, and then 4 to infinity. So it's going to be some of these intervals. Remember, in this case, we're looking for ones that are positive because I want to know when it's greater than 0. So let's write our numbers. If we have big negatives, these are all negatives, which results in a positive. So that's part of our answer. Next one, number like -4. That results in a negative. That's not part of my answer. A number like 0 is in the next group. This one's positive. That's part of my answer. Then we have a number like 1, for example. That results in a negative. That's not part of my answer. And finally, very big positive gives me positives right across the board, which is positive. So there's 3 intervals. In this case, for that to be true, x is going to be an element of that first interval, negative infinity to negative 5. It's also going to be part of negative 3 to a half. And it's also going to be a part of 4 to infinity. And that's that question. So those are those inequalities. So once again, pause it if you need, but that's that one. Next question says, determine the intervals of increase or decrease. So what I'm going to do is graph this one just to see what it looks like. And we can determine where it's going to increase or decrease. So let's have a look at what we've got. So if I'm trying to graph this, I know that we're going to have a, let's start with vertical asymptote maybe. In this case happens to be at 2. It's where the bottom is 2, or where the bottom would be 0. Horizontal asymptote, in this case, I divide the 2 leading coefficients. 2 divided by 1 is 2. Next, I'm looking for x-intercepts, where the top is equal to 0, which is 3 over 2. And y-intercepts, if I plug in 0 into the graph, I get y is equal to 1.5. So, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Draw my vertical asymptotes at 2. Horizontal asymptote at also 2. And our x-intercept at 1.5, so right here. So I know that it's going to be in the bottom left section of this graph. Y-intercept of 1.5. Right here. So I know our graph's going to be looking something like this. In this section, it's always decreasing. It's never rising as you go from right to left. Although up here it's decreasing very slowly. Down here it's decreasing really quickly, but it's always decreasing. So then the other spot is, well, where else is our graph going to be? Since there's no x-intercepts here, I can be pretty darn sure it's going to be up in the top corner here. And in this section here, it's also always decreasing. So right across the board from negative infinity to positive infinity, this graph's decreasing. All right, next one says we have an absolute value that is greater than or equal to 3. So basically, when we have the absolute value, remember that you can either break it up into positive, so it was x minus 2 over x is greater than or equal to 3, and the negative. Something along those lines. So what we're going to do is solve these. So for the first one, I cannot just multiply both sides by x. Actually, for both of them, can't just multiply both sides by x because x may be a negative number and I have to flip that sign. So what I'm going to have to do is bring 3 over to the other side. And I have to incorporate it with the like term. So I'm going to have to incorporate an x here and an x here. So essentially it's going to become x minus 2 minus 3x all over x has got to be greater than or equal to 0. And when I add the like terms together, we're going to have negative 2x minus 2 over x greater than or equal to 0. And I can common factor that. Then I'm going to do the same thing for the other side. I can distribute the negative inside first of all. It's going to be negative x plus 2 over x greater than or equal to 3. Same idea. I need to incorporate x on the other side, so it's going to come over just like it did. I'm going to have an x as my denominator, and it will end up looking something like this. Just like we did on the other side, right? We just brought 3 over, add an x to the top and bottom. Turns out here, when I add the like terms together, that. And I can common factor out -2. So I'm going to have to solve each of these ones and look at the intervals that we have that could apply. So for the first one, intervals will be x plus 1, and -2. Our x-intercepts happen where x is equal to -1. Our vertical asymptote happens where x is equal to 0. So I need to break up negative to positive infinity by -1 and 1. So I'm going to do that here. So negative infinity to -1, -1 to 0, and from 0 to infinity. Get our numbers here. All these are negatives. That results in a negative. Next, -1/2, for example, is an interval in there, which is positive. And lastly, if we have a positive number, results in a negative. So which ones is this true? So I want to know where it's greater than 0. So x is an element of the numbers from -1 to 0. Put square brackets because it's less than or equal to. I'm going to do the same thing on this side. Write my factors of x, -2, and 2x minus 1. Write my intervals that we have. So my intervals are going to be broken up by 0 for the bottom and half, 1/2. So first one's going to go from -infinity to 0, from 0 to 1/2, and then from 1/2 to infinity. Always being broken up by the x-intercepts. So when x is negative, big negative results in a negative. That's a negative value. So that's not part of my answer. How about 0 to 1/2? Well, it'll be positive, negative, and negative, which is positive. And finally, a big positive number would be plus, negative, plus, which is a negative. So the only intervals where this is true, in this case, x is an element from 0 to 1/2. So if I combine these from -1 to 0 and from 0 to 1/2, well, that means it's got to be everything from -1 to 1/2. It includes 0 in it as well. That's why we don't have to stop them at 0, because it's greater than or equal to 0. That's our interval for that one. That's 12. Continue on here. All right, for 13, it says the function, this, has a linear oblique asymptote. Determine the equation of the linear oblique asymptote. So since it's not a linear that we're dividing by, we have to use long division in this case. So we set it up like we know. When I divide, we got to figure out what value will make x cubed. The first one, well, it's going to be just x. So we're going to have x cubed plus 3x squared plus 5x. And what we're going to do is subtract them down. So the first term becomes 0. It's gone. Next one will become -x squared. And when I subtract down, we get -10x, and we bring down the 1. Then from there, we're going to figure out, well, I want to get -x squared with my first term. How am I going to get that? Well, I need to multiply by -1, because -1 times x squared is -x squared minus 3x minus 5. We're going to subtract down, so that's going to eliminate the first term. When we subtract down, we get -7x plus 6. That's our remainder. But we know when we look for our oblique asymptote, the remainder doesn't matter. What matters is the equation, which is y is equal to x minus 1 up top. That's our oblique asymptote in this case. Then it says, determine how from above or below the graph, approaches the oblique asymptote as x approaches infinity and as x approaches -infinity. So basically what it's saying is, here's our graph. Our oblique asymptote looks something like this. And it says, well, in the infinity part, is it coming from this side? Or is it coming from this side? So what I can do is choose a big value, like maybe 100. See, what is the value of our oblique asymptote at 100? So what I'm going to do is put that into our equation. Y is equal to 100 minus 1, which is 99. So a point on our oblique asymptote will be at 199. And then let's try our function. Let's put in a number like 100. So in this equation here, we take out our calculator, put in 100 for our function. I'll use a different color here. F of 100 is equal to negative 100.9, which is then above the oblique asymptote, since the oblique asymptote was negative 101, so it's higher on the y-axis, which means it must approach from above. For 14, we want to make an equation, and it tells us that we have a vertical asymptote at x is equal to 2, and x is equal to negative 3. So those are our brackets on the bottom, and on the top we have an x-intercept at 4, so we have x minus 4 on top. And that's equal to y. Now we're going to have a transformation. I'm going to have to put a on top here because we have a y-intercept when of 4, which means when x is equal to 0, y is equal to 4. So we'll input 4 for y and 0 for x as we go through and try to solve for a, whatever the transformation would be. On the bottom, 0 take away 2 is negative 2, and 0 plus 3 is positive 3. And when I multiply those ones together, we have 4 is equal to negative 4a over negative 6. And we can solve that by multiplying both sides by negative 6, which gives us negative 24 is equal to negative 4a, and divide by negative 4 on both sides. Gives us a is equal to 6. And we'll put that into our equation. And that's our final equation. That's an equation that has vertical asymptotes at 2 and negative 3, an x-intercept at 4, and a y-intercept at 4.